Exercise 1.3, we are going to do a few problems based on domain and range. Domain. Let us have an idea. What do you mean by the word domain? Domain tells me the set where the function is defined. F is a function from A to B, we say. This A only I call domain. What will be the conditions for this? Suppose I have F as P of X by Q of X. Wherever Q of X is 0, eliminate it from R. R stands for real numbers. So whenever you have a fraction, put the denominator 0, and we know in mathematics 0 is not allowed in the denominator. So wherever the denominator is becoming 0, exclude it from the real numbers. You have learnt it, excluded values in standard 10. Remember, so here to write domain, exclude the denominator 0 values from R. So this only we call domain. Suppose I have square root of something. Ensure what is inside the square root should be positive. So inside the square root, I have a function f of x. I must ensure this f of x must be greater than or equal to 0. We have learnt inside the square root, negative number comes, it becomes imaginary. Functions are real valued. So whenever square root comes, ensure what is inside the square root is always positive, or it can become equal to 0 also. Now we go on to the very first question in this model. Question number 6. Find the domain. The function given is 1 by 1 minus 2 sin x. Now what is the condition? There is a denominator. So put the denominator equal to 0. 1 minus 2 sin x equals to 0. Or this tells me minus 2 sin x equals to minus 1, or sin x equals to 1 by 2. Or you remember from trigonometry, sin x is half means it is 30 degrees. But we are in higher secondary. We do not write the angle in degrees. We write it in radians, and about this you will learn in trigonometry in detail. So x is equal to pi by 6. Now see, this is our angle system. 0, 90, 2 times 90, 3 times 90 and 4 times. It goes on and on. Pi by 6 is an angle here. Only one time it is pi by 6. No, I can make one round and come back here. These are circular functions. I go around, again I come back. So I go second round, again I come back. I go to third round, again I come back. So it is not like walking straight. If you walk straight, you don't come across same place again and again. But if you are circling around, the same place you will come across again and again. So pi by 6 will be met in so many rounds. How to write the general value? Again, this you will study in detail in trigonometry later. At present, remember the formula. Whenever it is sin x, whatever angle I get, write this formula. N pi plus minus 1 power n, whatever comes. So all these x values I must exclude. So now my question is domain. So what should I write for the domain? R minus where denominator is becoming 0. Or I will write R minus these values. N pi plus minus 1 power n pi by 6. Exclude this value where n is an integer. N, I said rounds. 1 round, 2 round. I cannot make half a round and all. So 1 round, 2 rounds, 3 rounds like that. So n tells me how many rounds I make. So that round I can go in clockwise, so it is negative. I can go in anti-clockwise, so it is positive. So generally we say n is an integer. So this question deals with trigonometry. This formula alone we will study in detail in trigonometry chapter. Question number 7, exercise 1.3. Find the largest possible domain for f of x. See, I told you two conditions for domain. Number 1, denominator should not become 0. So, x square minus 9, 0 means x square equals to 9 or x is equal to plus or minus 3 must not come in the question. Excluded value. The second condition tells me whenever square root is there, whatever is inside the square root must be positive. So, my first idea, root of 4 minus x square. So 4 minus x square must be greater than or equal to 0. Or I will say x square minus 4. Whenever I change the symbol, inequality reverses. All this in detail we will study in second chapter. So whenever we change the symbol, greater becomes less. Or I will say this as x plus 2, x minus 2. What formula? A square minus b square. A plus b, a minus b less than or equal to 0. Whenever I have this less than or equal to, I understand x belongs to the interval. If I put plus 2, I will change the symbol. If I have minus 2, I will change the symbol. So this is the interval. X, this is an interval, not only two values. All the numbers from minus 2 to plus 2. So this is an interval. This is for the numerator I did. What is the denominator? X square minus 9. Because it is denominator, I should not put equal to 0. I will put only greater than 0. Equal to cannot come for the denominator. The next idea. This is also a square minus b square pattern. Write it as a plus b into a minus b, that is greater than 0. When it is below 0, I said inside the interval. When it is greater than 0, I will say x lies outside. Plus 3 means minus 3. Minus 3 means plus 3. So, I will say x lies outside minus 3 and plus 3. What do you mean by x lying outside? It's a number line. Minus infinity to plus infinity. This is minus 3. This is plus 3. Outside tells me this interval. So, where will I write? Minus infinity to minus 3. 3 to infinity, and both I have, so union. What about this one? This tells me from minus 2 to plus 2. I have this area. Here it is closed interval. So I can put a thick dot. Here it is open interval. I must put an open dot like this. Now tell me, is there any common portion for this? Numerator tells me I must be inside minus 2 and 2. Denominator tells me I should be outside 3 or outside minus 3. There is no common portion. So we will say no common region for numerator and denominator. Therefore, I cannot declare a common domain for this. So for the particular function, we cannot say any possible domain. So we will take and write the answer. There is no domain for f of x. Question number 8. Find range for the function 1 by 2 cos x minus 1. For domain, I gave you two ideas. Denominator should not become 0 and root symbol comes, what is inside the root must be positive. When it is range, depending on whatever is coming in the problem, we will decide. Whenever sine or cos is coming, we will learn in the next exercise how to draw sine, cos and all. They are like wave motion up and down. You have studied sin x, cos x and all in standard 10. The maximum value of cos x is plus 1 and the minimum value, same thing for sine also. Since it goes up and down, you cannot see a cos curve like this. So the cos curve maximum value plus 1, minimum value minus 1. So we will write range of cos x is minus 1 to 1 only. So how will I write? Cos x is between, see we write like this way, between, cos x is between minus 1 and plus 1. See the curve? It is from minus 1 to plus 1. My question wants 2 cos x. So multiply by 2. What is the next step? Multiply by 2. So minus 1 into 2 less than or equal to 2 cos x less than or equal to 1 into 2. Now I want minus 1. So subtract 1 throughout. Minus 2 minus 1 less than or equal to 2 cos x minus 1 less than or equal to 2 minus 1. So what is my answer? Minus 3 less than or equal to 2 cos x minus 1 less than or equal to 1. So I get the answer 2 cos x minus 1 is between minus 3 to 1. I want reciprocal. So what do we do? Taking reciprocal. See, in the very first step I said, when you multiply by a negative number, inequality reverses. The same idea, when I take reciprocal also, inequality will reverse. That is, less comes, it will become greater. So taking reciprocal, minus 1 by 3 greater than or equal to 1 by 2 cos x minus 1 greater than or equal to reciprocal of 1 is 1 by 1. So what is my answer? Minus 1 by 3 greater than or equal to 1 by 2 cos x minus 1 greater than or equal to 1. Whenever it is less than, I write interval like this. Whenever it is greater than, I mark it outside. So less tells me inside, greater tells me outside. These are the two numbers, minus 1 by 3 and 1. This symbol tells me it is outside. So how do you write the interval? X belongs to the interval minus infinity to minus 1 by 3 and 1 to infinity. And what symbol we put? Both. So I am joining the two. So minus 1 by 3 greater than or equal to symbol comes. Let us remember, we should mark the two numbers and we will shade outside. Greater tells me outside, less tells me inside. Inside I will write interval like this. Greater I will write interval like this. And this is the range of the given function. Exercise 1.3, question number 9. Show that the relation xy equals to minus 2 is a function for a suitable domain. So we need to find out the domain and range when I declare it as a function. Given xy equals to minus 2. What is y from here? It is minus 2 divided by x. When will I call it as a function? What is the formula for the domain? R, the set of real numbers, minus where the denominator is equal to 0. That is R minus where the denominator is 0. Denominator is x which is equal to 0. I have to exclude from the set of real numbers. So my answer is R minus 0. So what is the domain for the function? It is R minus 0. From here, if I write what is x? X will be minus 2 by y. So y, this also should not become 0. So the range is also R minus 0. I can also declare the function is 1, 1. See, y is equal to minus 2 by x. That is y equal to f of x. Let me take. Take f of x1 equals to f of x2. What is f of x1? Minus 2 by x1. What is f of x2? Minus 2 by x2. If I cancel minus 2 and minus 2, x1 is equal to x2. So I am able to prove when the images are equal, the elements are also equal. So f of x1 equals to f of x2 implies x1 equals to x2. Therefore, f is a 1, 1 function. I can also say f is an onto function because the range I have declared is r minus 0. So f is also an onto function. Exercise 1.3, question number 13. Weight of the muscle of a man is a function of his body weight x. Body weight is given as x and can be expressed as W of x equals 0.35x. The question is determine the domain. So when I say determine the domain, there is no square root to check positive. There is no denominator also. But in word problems, let us read it again and again, check whether decimals can come or only whole numbers can come. Whether negative can come or only positive can come. Here weight of the muscle. So weight can be a decimal number. Nobody will be exactly 10 kilogram, 20 kilogram like that. So it would be 10.18, 10.2, 11.7. So like that. So decimals can come. Which shouldn't come? You cannot say I am minus 5.3 weight. I am minus 50 kilogram weight. So weight cannot be negative. So we will say weight cannot be negative. So that is the main thing that we want to say. So when weight cannot be negative, domain will definitely be x greater than 0, and that is enough. So it's a big problem, but the question is very simple. Find only the domain. Given W of x is 0.35x, where x represents the body weight, we need to find the domain. Weight cannot be negative, so domain should be x greater than 0.